4 participants already. So good morning, everybody, and a very warm welcome to another section of the AVEVA Academic Digital Transformation webinar. It is very important that we understand the vision of why we're having this. So like yesterday, I read a piece before we started, but I'm going to do that right away so that we get to understand properly why this is we're organizing this. Lunadec and AVEVA is putting this together to make sure that we're reaching out to very young engineers, not just limited engineers, also professionals, especially in our country and also across Africa. So the purpose of today's webinar, just like we mentioned yesterday, was to educate, inform, inspire, empower, and engage with the goal of empowering African digital future through unlocking global career with AVEVA technology. Over the past few minutes, we're going to have Kwasi comes up. Kwasi is going to come up, and over the next few minutes, Kwasi will be coming up to share on the state of the art technology, how they are deployed to enhance human performance for improved productivity and stability. Today's AVEVA ecosystem and solution is widely implemented globally in digitalizing assets such as refineries, manufacturing plants, oil and gas facility, power plants, energy systems, marine vessels, smart factories, etc. Through digitalization and digital transformation and gathering insights, infographic and visualization translate into better decision making. Today, millions of dollars is being saved globally through implementing digital twin for predictive and prescriptive operations and maintenance. Furthermore, some exciting careers include system integrators, IoT, OT specialists, industrial software engineers, data analysts and AI specialists, digital transformation consultants, operations, and system engineers. Skills require technical plus soft skills. It is important to note that AVEVA makes the present solution or presented solution available for classroom teaching and research. So we would be pleased to engage with the right persons in learning institutions such as universities, polytechnics, monotechnics, and technical colleges. So like what we have on the screen, we have the QR code, please scan so that you can be able to join our community. This series is going to extend to 23rd of this month, that's on Thursday. And before we kickstart and before I call Kwasi to have the room, we're just going to discuss a little bit on the housekeeping rules. So my name is Ugochukwu, and I'll be your coordinator and moderator for today's section. So we are absolutely delighted to have you with us. Every person that is attending, every participant, we're so excited having you. Whether you're joining from Yenigua, you're joining from Lagos, you're joining from Abuja, or any part across Africa and also beyond. So before we start, it is important that we have some housekeeping rules, like I mentioned initially. First is, please keep your microphones muted unless you're invited to speak. You can use the chat box, which is very critical. A lot of engagement will be happening there. And we're going to have a survey too. At any point to share your feedbacks, your questions, please use the chat box. Questions or comments, we get those. We'll get a Q&A section. So we're going to, after the presentation by Kwasi, we're going to have a Q&A section where you can ask your questions and also you can also give your feedbacks. So this section is going to be recorded for replay and also for, we're going to be publicizing it on our YouTube channel. I think my colleagues are going to they will put the link on the chat box so that you could click on it, especially for yesterday's section with Jani, which was very, very, very educative and insightful. So for us, it is critical that we understand that this section today is going to be for 1 hour, 10 minutes. But I can tell you that today's section will be as very, very educative as yesterday's. So we'll be discussing on the PI system, and Kwasi is going to be doing that, doing justice to that. So I'm going to do a little introduction of our principal consultant, Dr. Ibilola Amao. So I'll just read her profile a little brief on it, a little bit of it. So it's just a brief so that we can have, then I'll also introduce Kwasi, then we can kickstart the section. So Dr. Ibilola Amao, Dr. Ibilola Amao is a distinguished Nigerian British engineer, an entrepreneur, and a STEM advocate, serving as principal consultant of Lunade Global Services, a multi-award winning, human-owned engineering technology and information management firm operating across Africa, Europe, and the Middle East and UK. She holds a first-class honor degree in civil and structural engineering from Queen's Mary University of London and a PhD in computer-aided design and drafting from the University of Brantford. Dr. Amao has also completed the executive management program at top institutions, including Manchester Business School and others. With over 3 decades of experience, Dr. Amao leads Lunadec in delivering engineering technology solutions, digital transformation initiative, and human capital development programs across energy, power, infrastructure, manufacturing, and oil and gas sector. Under her leadership, Lunadec has trained thousands of engineers and empower over 100,000 talent while fostering digital and professional skill development. She is a respected fellow of the Institute of Directors, Energy Institute UK, Nigerian Society of Engineers, and the Nigerian Academy of Engineering, and serve on international boards and expert panels, including the Energy Institute and the Royal Academy of Engineering UK African Prize Judges Panel. Dr. Amao is also a co-founder of the Women in Energy Network and actively champions diversity, youth empowerment, and women participation in STEM. Her contributions have earned her numerous recognition, including the Forbes African Rising Star Award, C3E International Women of Distinction Award. We Connect Rise to the Challenge Award and Fellowship with Vital Voices. So I'll move over to our presenter today and also our instructor today, or facilitator today from AVEVA. So Kwasi, hope I pronounce your name well. Please pardon me if I don't. Kwasi Ashar has 8 years of experience at AVEVA with a background in chemical engineering. Kwasi combines technical knowledge with practical industry experience to support customers using the AVEVA Pi system. In his role, Kwasi works with customers to resolve technical issues and queries, ensuring the reliable operations of their critical systems. He's also involved in delivering and preparing technical training courses, helping engineers and technical teams gain practical skills and confidence in using the platform. In addition, he has extensive experience supporting installation and migration services for customers' production system. He is passionate about helping engineers understand how industrial software is used. In this section, he will give an introduction to the AVEVA Pi system, covering key concepts, theories, and practical examples. Please let us make welcome. Let's put our hands together like they used to say in Nigeria, and let's welcome Kwasi. Kwasi, thank you very much for being here. So you can take the room, sir. Thank you.
Thank you so much, Ogochukwe. I think I must have pronounced your name incorrectly, but it's pardon me as well for that. So my name is Qasim Askar. I'm based out of London, and I've been working with AVEVA for about 8 years now. And I will start off by giving you an overview of myself. Just a minute, if I can share my screen, please.
So we have, let me just mention this. At the moment, we have 53 participants. That's really, really an upshoot. Thank you very much for joining. I think let's keep before Quasim start, please. Let's keep writing our names, please. Your name, your location, and also your profession is very necessary. Thank you very much. Thank you. Thank you.
Okay, again, thanks for the introduction, and I hope you can see my screen as well. Just give me a thumbs up if that's all clear and you can see my presentation screen, and we'll get going. So this session is regarding the PI system. My name is Qasim Askar, and I'm a technical and product support engineer for AVEVA, specifically the PI system. Fun fact before I get started is that I have actually been to West Africa, not to Nigeria, but to Cameroon back in 2019. Okay, an overview of what we will discuss in this session. So we're going to start with the foundations of the PI system. So that will overview what our portfolio is and where what the goals of our portfolio are and where the PI system fits into those, a bit of background and history about PI system. Then we'll go into some product details, giving you a bit of a deep dive into core components, what are the characteristics of the PI system, how data is collected, key pillars of the PI system infrastructure. And then the next part is going to focus on the AVEVA cloud integration, how the PI system connects to our cloud platform, and how we share that data to our AVEVA cloud platform. And finally, I'll give you a demo of one of our software components where everything is brought up into, which is AVEVA PI Vision. And we'll finish with some Q&A. So the goal of AVEVA and our softwares is to deliver operations and design and optimization software. That top pillar there is what underpins everything that we do within AVEVA. But that also, we want to empower the usage of our data internally within the AVEVA software platforms, but also externally, being able to make data sharing easy to external third-party softwares. So this dash boundary around the edge there sort of gives you an indication that it's not completely bound within what we provide you. It's our goal is to be number one in industrial software and providing industrial software to customers and making it easy for them to integrate within their organizations. Okay, and the PI system is a key part of that industrial software architecture. We focus really on this aspect where it's the operations and real-time data collection. The PI system serves as a foundation of that industrial information management, making real-time data collection, aggregation of data from critical systems easy, and then contextualizing that data, building upon it, making it valuable and accessible for the rest of the software suite. And then on top of that, we build into asset performance and visualization. So the route that the PI system, or the location where it lies within this AVEVA architecture, is operations, industrial information management, asset performance, managing those assets, and then visualization across our company's network. So the data that exists across a particular company's geospatial network is very complex. Often it's hard to manage and hard to track, and it has many destinations simultaneously. Those user bases, the assets that exist, are distributed across our network, and they have many different use cases. So there is things like naming and aliasing legacy sources, buffering, backfilling, those use cases which make the path for getting our raw data much harder, and then using that data quite difficult. As the requirements will grow, then the time series functions also need to match those. So things like tracking batches, event frames, analytics, meeting compliance and regulation requirements. The one mentioned there, 21 CFR, applicable to food and drug administration, uh, means that our software needs to provide correct governance and traceability to fit with those industry requirements. So that's where the AVEVA PI system really comes in, that making the collection of operational data reliable and then also contextualizing and providing it accurately to the consumers of the data. So to touch on then the AVEVA PI system, we know that it's for operational data management. That's the core principle that we follow. We want to make operational data easy to collect, easy to store, and then delivering that across our industrial architecture. So the AVEVA PI system is really a real-time data infrastructure. Its job is then to collect, historize, and deliver from our sources, so sensors, equipment, control system, so that it's then available to use across the organization. Each of the core capabilities will focus on making data and connectivity easy across the business. We have over 450 interfaces to be able to connect to many industrial protocols, meaning that we can collect data from almost all data sources. And this provides then the ability to use that data, efficiently contextualize the real-time insights, and then Pi is specifically built to handle high-frequency real-time data. Globally, we have more than almost 20,000 installations of the Pi system. We manage billions of streams for our customers, and a lot of those streams are handled on the customer side, and they are in complete control of their data. So where does the Pi system come from, and how long has it been around? So our founding father, which is Dr. Patrick Kennedy, may he rest in peace, was the first to develop the Pi system. Back in 1980, that's where the legacy company OSI Soft was identified, and that's where the first Pi system was made. Became a foundation of many industries, mainly focusing on oil and gas at that time to help them capture and manage their data, and then expanding out further. So by the 1990s, it was a much broader software suite, making client and server architecture possible, and helping the Pi system become a platform that others could also build on, meaning it's a foundation of the real-time data to then be accessible across a wider industrial architecture. By the 2000s, we introduced a component called the Pi framework, which helped contextualization of data easier, making the data more valuable for the wider business who were not directly involved with setting up the software or setting up those data sources, but they also needed to be able to work with those data. Then we were acquired by AVEVA around 2018-19 timeframe. Now we fit into a much more comprehensive, wider industrial portfolio. And then in 2020s, we have introduced our cloud platform. We refer to as AVEVA Connect, making integration with wider industry requirements easier, meaning the data is no longer held on premises, but available in the cloud, minimizing any requirements for end users and companies to install things on their own company networks. So managing data, as we mentioned, is very complex. There's so many different data sources out there, and the requirements for using those data from those data sources is very complex. So we have a wide range of routes that the data may be currently been taking to make its way through, be processed, and then be used by consumers of the data. But that's where the PI system comes in. The PI system is serving as a middle point between our data sources and our consumers. We refer those stages collecting, enriching the data, visualizing, making it easier for the data consumers to access that data. And then not just on the on-premises perspective, but also within the cloud and at the edge. Modern PI system includes ability to share data easily between users or across different companies or within the same organization with a wider range of tools and softwares connecting directly to the cloud. And they're interoperable, meaning that you may have an on-premises system that you're then sending data to the cloud. But even more recently, we have what's called AVEVA or PI system at the edge, being able to connect and store data at the edge, where systems and networks may be unstable. We can do the processing and storing of data at the edge, and then feed that into your on-premises and cloud systems when the network and conditions are stable. So those three platforms and systems work in tandem with one another to be able to reliably store data wherever the use case. Whether there's a regulatory requirement to make sure that everything is on premises, then those can be met by on-premises core PI system, but then at the edge and the cloud as needed, depending on the use cases. So where does this fit in? So we look at the colors on the previous slide and remember those as we go forward. This is where it fits into the wider PI system and the specific component names we refer to. So when we talk about the PI system at the edge, we have software called PI adapters, which are very lightweight, can be used on not just Windows OSs, but Linux and very lightweight devices and easy to configure with command line. The Edge Data Store is a software which allows storage or temporary storage of data at the edge, and then feeding that into cloud or core PI system when the network is restored. So when you have high latency networks where you can't be setting a lot of data continuously and the latency is varying, that's where Edge Data Store becomes very important. Being able to configure those as close as possible to your assets. And then those edge requirements can be met simultaneously with our other collection software, such as PI interfaces and connectors, which work historically with the control system and other historians. And then that central component of our architecture is the AVEVA PI server. I'll dive into more details about that later. And then integrating with other AVEVA platforms to make data sharing and accessibility across third-party softwares easier. Okay, let's break this down and really understand each layer of our PI system. So the first component of the PI system is the collection layer. So this can be done at the edge, directly to the cloud, or into our AVEVA core PI system. The collection layer is there to connect to any asset, regardless of the protocol or the vendor being used. It supports over 200 industrial protocols, such as OPC, SQL servers. It can connect to even text files. It can process any sort of industrial data, and these have been developed since the founding of the company back in 1980. So you can imagine 40 plus years of interface development, adapter development, and connector development to make data accessibility from our sources easy, making collection streamlined and uh, yeah, and reliable. The development of those is maintained by us, and the configuration is very simple. In most cases, for the interface and the connectors, no programming is required, and even for those command line tools, it's very easy to configure our software. You don't need to do and know or be a programmer to configure the software. And the next stage is to store and enrich the data. We want to have high frequency, large volumes of data, providing context to our end users, and running real-time analytics and calculations on top of that data to make it more valuable, and then being able to capture the key moments across our data, such as temperature, pressure excursions, and important time periods that need to be acted on by end users. And finally, okay, before we dive into more detail about the visualization delivering, I want to expand on the store and enrich phase of the PI system. But before we get into it, I want to hear from the participants. How many of you have heard about the PI system before? If you can just give us a response in the chat, that would be great. How many? Who has heard of PI system before?
Okay, let us have that in the chat box. So your feedbacks, please just give it. So I have Chidi, age of 4, he said I have. So Mohammed Musa said I. So let's take it that is I have too. Scholastica Anadi, I have. Daniel Bene, I have. So okay. Dominic too, I have. Charles, I have. So we're having a lot of people here saying that they have. So
Excellent. That's really good.
okay.
And just a follow-up question from that. Who has actually worked with the PI system before?
Olajide said he also have heard about it. So
Okay, excellent. Excellent. So yeah, continue to add your feedback there. And yeah, it's great to hear that you have worked with the PI system before. So you may have some additional knowledge already, and some of this information may be already familiar with. But yeah, thank you again for everyone's feedback. Okay, going into more details about the store and enrich phase of the PI system, maybe a reminder for some of you. So that is the software stack that we refer to as the PI server. It's built up of a few components or key softwares, and the first of those is the PI data archive. To be able to store our high frequency data, in some cases, customers have millions of streams of data. Some of the bigger industrial oil and gas players you may be able to think of, they have millions and millions of streams of data per system, distributed geographically. And that data archive is optimized to work with that high frequency data, and then also maintaining the fidelity, maintaining the exact meaning of the data without compromise, without filtering more than what you required. There is filtering capabilities, but you define that. Making that data constantly available and online for other systems to be able to process. And then making future data also storable. So not just historical data, you can make calculations and insights and store future data within the PyData archive layer. So that's one of the softwares that make up the Pi server stack. To build on top of that data that you've now stored, man, you've got all this rich information from many different data sources, RDBMS, SQL servers, text files, OPC servers, Modbus devices. All of this data has now been stored with its original timestamps and data, no compromise with the data, and it's there and available for you to use. How can we use that more efficiently? Because having millions of streams or hundreds of thousands of streams, which are somewhat disconnected at this point, we cannot remember the name of every stream to process. We need something to make it easier for us to manage that those large quantities of streams. Okay. And we refer to that component as a Pi asset framework. This means that we're not looking at individual tag names, rather we will look and build a hierarchy of our system. So we have properties and tags which are associated to many different assets and equipments, and we need to categorize those as and where they lay, and also set up a hierarchy for our particular operations. That hierarchy is not just one hierarchy that is applicable to the whole business. You could have multiple different hierarchies, meaning that one user may want to look at just pumps, other users may want to look at the pumping station overall, other users may want to look at things geographically, some users may not be focused on particular equipment. So you can have multiple different hierarchies to suit different use cases. But the importance of creating a hierarchy means that if someone else was to browse that data, they would easily be able to figure out what is going on with it, rather than if we just had a tag name, that would be quite hard for the end user who doesn't know where that's coming from to then find out about that information, about that data point. We contextualize, we label it with human-friendly names, we add metadata and context, not just a raw value, but also things like installation dates, manufacturers, some information that makes it really rich for usage in across different softwares. And we standardize it so that if we have 2 pumps, we create a template for one and be able to use that across other pumps with similar characteristics. So that we've collected the data, we've contextualized it with the Pi asset framework layer. The next layer was the asset analytics. We want to add value to the data that we've now collected. So we have a built-in array of functions within our asset analytics to make doing calculations on the data easy. We can migrate equations from other tools quite easily by pasting them in, just changing the function being used. And once we set up a baseline of calculations that we need for a particular pump, for example, we may want to calculate average flow rates for a pump, or tracking when pressures are high or low. So we've got analytics in place for that. We've done that for pump 1. We will then templatize and roll that out to all pumps, minimizing the amount of work that is needed. And we don't just do that for the real-time data. If we had a historical data for a few years, we can backfill and calculate that for the historical data as well. So we've added value by using analytics, but even more so than that, we have a software called Pi Event Frames, where we capture important time periods of data, being able to capture things that actually matter and store those in what we call event frames. So we capture events based on the raw values, such as process thresholds or indicators for certain KPIs, and then making that easy and accessible to use in other softwares. So common event frames that we may see are tank level monitoring. You could have even shift monitoring, where you've got a shift between 8 a.m. and 8 p.m., for example, and you need to monitor the statistics for that shift so you can compare it over a time period. So it's really valuable being able to capture information over a set time period or capturing the time period based on a set of conditions. And then finally, we've got all this really highly valuable information. We need to let people know about them. So your engineers, operators aren't always going to be monitoring the data. They've got other stuff to do. So when something occurs, they get alerted as and when. So the notifications via email or updating a web surface connected to, say, a SQL maintenance database for usage across other MES platforms, meaning that individuals and locations that need to be notified of a particular event, such as low efficiency, high temperature, low level alarms, high level alarms, they get notified by email when those occur, rather than having to monitor the data constantly. Okay, so we've got that software stack, which we refer to as the AVEVA Pi server, but it has within it a few combinations of softwares. You don't have to use all of those. You can choose to use only, say, data archive and asset framework analytics. You don't need to use event frames and notifications, but it's available and there to enrich the usage of the data. And finally, we need to deliver that data to our user base. How can we do that? We need to make sure that the data is available in real time for them, that the metrics that we've calculated are also available in real time and being presented to the end users. Those event frames are viewable in dashboards, for example, and they're not just for one user. It needs to be available at scale across the entire business for different users. And then also providing ability for end users to programmatically access data, because there may be people that don't want to use our built-in softwares, which they're fixed to what they can and cannot do. They may want to access data, pull the information that they need, and then feed that into their own industrial software platform that they've custom developed. One of the key softwares we provide for data visualization is the AVEVA Pi Vision platform. It's really straightforward, real-time, intuitive to use, and self-service offers for end users. It's a scalable solution, meaning that you don't need to install anything on a particular laptop or a particular PC for it to work. As long as you've got HTML5 compliant browser, no other plugins are required. It will work as long as you have the permissions to access this particular web client and you have the correct web browser. It's intuitive, meaning you can drag and drop. It will have the asset-based features, so you don't need to know tag names. It will build on those hierarchies that you have already got in the asset framework. It updates in real time every 5 seconds by default, and it's optimized for use on desktop and also mobile platforms. Key features like trends, tables, gauges, we'll see a bit more of that in the demo. And it has ad hoc trending, easy sharing, and extensibility features available. And then for users that really like Excel, Excel is not going anywhere. We know the power of Microsoft Excel and how integrated it is within almost every business. So the ability to add in Pi data to the Excel reports is really valuable. And we have a software called Pi Data Link, which allows easy usage of that data in Excel, meaning that we can do the same thing where we extract real-time data on a frequent basis, access our event frames, access the analytical outputs, and bring them into Microsoft Excel in a reusable report. Then we extend this. So we've got our core software stack So the collection layer, adapters, connectors, interfaces. We feed that into the Pi server. We enrich the data. We've given it to our end users via Pi Vision, Pi Data Link. They can extract it with programmatic tools, which are available with the Pi system as well. And then with the other use cases, now we've got it in the core Pi system. We also want it in the cloud. We don't want to have to have end users install anything. They should be able to access it from via the internet wherever they are. Our cloud platform that Pi Data feeds directly into is called Connect. Connect is offering an optimized experience for industrial data usage in the cloud. The way that we unify data and allow for AI to be used on top of the portfolio that we've given, and offer trusted information within the cloud, meaning that if you've got many different AVEVA softwares, Pi System software stack is just one of those. Bring all that data into a central place, which is Connect, and making it a single source of the truth, providing not just your organization, but also sharing that data across multiple organizations easy. And you choose what you want to share. And then that leads to insights which are actionable, not just by yourself and your company, but other stakeholders of that data. So we unify not just one or two different applications and data sources, but hundreds of different applications and data sources, and offers ability to make a customized experience within the cloud. What this means is that we can eliminate some of those customer challenges where information and data is in silos in a particular business, making it available to other teams, external stakeholders, where they've had to previously wait for that data. It makes that streamlined in terms of data sharing and automated, where you don't have to manually go and extract a set of data. It will automatically be fed in at the defined time period and for the defined assets. Okay, so then we use the ability to aggregate all of our points into the cloud to serve our virtual data users, and then making that data available near to real time. And then we scale our data usage across multiple applications. So making data sharing from Pi into the cloud and then to any platform that can connect to our Connect platform. This is just an example of what it may look like. So AVEVA Connect Data Services, that's the data center of our Connect platform, where we have third-party data sources, AVEVA apps and data sources. That's where the Pi system would come in there. We have the ability, and we have software that feeds directly. So again, it's not customized. It's all available within our software stack to feed the data into cloud data services. And we do similar things that we do on premises, being able to store the data, view, shape the data, and then share that across. Again, this is then not limited just to your organization. We have the ability to have other partners in the industrial ecosystem view the data, and third-party apps that you can programmatically and with built-in connectors send data to, such as Power BI. So that's our AVEVA Connect Data Services. And finally, Connect Visualization. Similar to Pi Vision, we have the on-premise application. The same dashboarding and customization ability is available within the cloud. So it means that they directly access by the internet the Connect Visualization platform, and we're able to design and create the dashboards as needed there. So it means that we can have tailored views, tailored displays for different people across the software suite. That gives you an overview of how Pi System fits in, where we collect the data, how we collect the data, and then how we feed it into the end users. I want to give you a view of what it looks to our end users with a demo now. Going through the entire software stack would take days actually to understand each one. I don't want to overwhelm you with each of our individual software pieces. I want to give you the end view of what you can achieve. It gives you a bit of an insight into the what is required to get there, and then also how easy it is to use. Okay. All right, so this is the landing page that um, would be the same for every single Pi Vision user. So I'm going to give you a demo of our Pi Vision app, platform. I've got it in full screen there, but similar to how I've got URL to access our Pi Vision, you as an end user, if you had an installation of Pi System or Pi Vision, you would access it via that website URL that has been defined by your administrators. For the sake of this, I'll keep it in full screen mode for you to be easier to view. So this is the landing page, the homepage of Pi Vision, where existing displays can be viewed and accessed. So if I was to go into a particular folder, I'll be able to see displays that exist for that particular use case or that part of our business. A lot of the data in this particular Pi Vision platform is simulation data to give you an idea of different industries. I will give you one built-in example later. So, but first, let's start with showing you how easy, quick, and intuitive it is to be able to use the data within our Pi system using Pi Vision. So go and create a new display first here on the top right here, just to give you an overview of what is being shown here. So on the left-hand side, we have got 3 panes or 4 panes there. One is the assets view. You can do calculations. We've got a graphics library and then events viewing. And then when you click on the assets pane, which we'll be focusing on here for this part of the demo, we've got different symbols that we can use to present our data in different ways. All of the different databases available. So this is what exists in our Pi Asset Framework and Pi Data Archive. And this is what we'll navigate to access our data and the points associated to those assets. In the middle here, we have the build view, where we will be creating our dashboard. And then we have different options to be able to be in build mode, exporting information, adding images, for example, and a range of different options. But it's, to say the least, it's very intuitive and quick to get used to. Those of you that have done trainings already will know how easy it is to use Pi Vision and what you can achieve within a short time period. So I'm going to go ahead and build you one dashboard using our oil and gas downstream database. So the goal here, before I start creating it, is that I'll show you how we can create a dashboard to monitor some pumps across a particular part of our hierarchy, a different particular location. I want to be able to monitor the key characteristics of our pumps within a quick and intuitive dashboard. So I'm going to go into firstly navigating the hierarchy. Okay. So we'll navigate the hierarchy on the top here into downstream. Then we go into the location where those pumps may exist. It's going to be purely a pump display. So it's Petrolog FCC, the location. You see how the hierarchy is being shown now. I'll choose one particular location and a pump to begin with. So I've now chosen my asset and I've clicked on it. Using that, it's easy to select the asset and then be able to see the associated attributes to that asset as follows in the attributes pane at the bottom here. So associated to pump 1, and we've got all of these attributes. These attributes have been built in our asset framework application. This hierarchy, all of these temperatures, vibrations, metadata, all exists in the Pi asset framework. And then behind the asset framework is a data archive for those real-time data pieces. Let's start off with the naming or creating a dashboard. So I'll start with the asset name. I'm going to choose the type of symbol that I want to use at the top here. So in this case, I'm going to use the symbol icon for for single value. Bring that onto display as follows. And this just gives me a dynamic changing asset information. So if I was to choose a different pump, that will update automatically from the drop-down menu at the top. So now I've got the asset name. Let's add further information about the asset. So I'm going to start with some radial gauges. So at the top here, I've got a range of gauges, vertical, horizontal, and radial. I'm going to use a radial gauge to display some key process data, such as the current being pulled by the pump speed, the discharge pressure. So let's grab one of those to begin with. Choose the radial gauge first, and then drag and drop that onto the display as follows. And I can choose to easily configure how I want that gauge to look. So I'll just give you an example with the pointer. I will change the coloring if I need to. So the visibility of what is the label of that data point. Instead of it showing the pump name, which I already have at the top, I just want it to show the property that I'm monitoring there. Okay. So now I've got one format that I want to use. I can easily copy and paste that a couple of times. I can align those symbols at the top here and distribute them vertically. And then drag and drop on top. So at the moment they're all amps, so the current through the pump. I want to change the property monitoring, so I can use discharge pressure for that one, and then the pump speed here. So quickly and easy is to reflect the property that I want with the exact same format defined. Let's add some more information about this pump, such as vibration monitoring. I may want to keep an eye on some key vibrational parameters for the pumps, and I'll do that within a trend. So at the top here, I'll choose the symbol I want to represent this data with, select in bulk the attributes I want to show on that trend, and then drag and drop those on the display as follows. And again, be able to quickly and easily edit that. Let's need to add a title, for example, vibration monitoring, for example. And we can change the colorings of the display if needed. Choose to set the scales as single or multiple, choose data points or for it to be a trend line, scales inside or outside, as follows. Okay. Now I've got a trend with the key information, and the information displayed on that trend is for an 8-hour period, matching up the time scale of the trend itself, of the display itself. So I've got some information. Let's build on with that with a few different symbols, such as another gauge for the volumetric flow rate of the pump. So we'll choose the symbol we want, find the volumetric discharge flow, and add that as follows. Again, editing that for the visibility as needed. Say if I wasn't happy with the symbol, I can easily change that symbol to the type of gauge I want. Maybe I wanted a horizontal gauge instead. So I can easily put that one on the display as follows. As such, how about some metadata about this pump? So let's choose a table icon now at the top on the left-hand side. Or then find the metadata that is applicable. So the equipment details, select all the information I want, such as installation date, serial numbers, etc. Put that metadata on the display. I can remove columns that I don't need. So go to the configuration. We can remove description, for example, and we can remove the units. In this case, only showing the value and the name of the parameter, the metadata parameter. Okay, so now we've got metadata about our pump. We've got some key process information such as speeds, discharge rates, vibrational information about the pump. How about if I want to be having more information about different pumps and easily be able to navigate to the pump that has an issue? For example, I may want to have a table which is color scheme to show me when pump speed is above a set threshold. So let's add in that information. I'm going to start with just an asset comparison table and finding the pump speed information as follows and dragging and dropping that just there. But this is only showing me one pump. How can I easily make it show me the speed for all of the other pumps? So we can right click on it and edit the search criteria to make it look at different level of the hierarchy. For example, the entire database at the top level, and then return for me all the assets that lie underneath the top level, which is Petrolux downstream, that match up a certain condition. So it's going to be all assets that are of this type, the pump. Now if I expand that out, I've got all of them showing up. But let's go one step further and configure this table slightly. I'm gonna make it easier to see information about those pumps as follows. I want some color scheme. So when an asset is going above or below a certain value, I want it to change color. So I can right click and choose to add what's called multi-state. This is adding a visual alarm to the display. I'll do it for the speed. I'll enable the multi-state and then define some thresholds. Example, say if it's 3000, I want to say, okay, the top level threshold is 3000. I want it to flash red. And then underneath that amber, say 2000. And then below that, it'll be in green if it's less than 1000. Okay, now we've got color scheming to match up when a certain pump speed has exceeded a certain threshold. Okay, so at the moment they're all red and amber because they're above 2000 and above 1000. As it drops below 1000, maybe that's the desired threshold for them to operate in, they will go to green. We can add some navigation links because at the moment this display is only updating with pump 1 information. So say I wanted to focus on, because pump 1 is in amber, that may be okay, but the pumps are in red. I want to quickly be able to navigate to those. Rather than them to go at the top, drop down here, I want to be able to click and navigate to those. So we can add what's called navigation links. We can change the context of the current display using the current asset. So if I now go out of update mode, I can choose a different pump and the display will update with information, the metadata, etc. about that pump. So for example, FCC pump 3, now we've got information about the FCC pump 3 on the display, such as the flow rates, vibrational data, etc. So how quick and easy it is to develop a contextual display. And finally, let's show you the event frames and how easy it is to use event frames on a display. Maybe I want to add key event frame information to this combined pump display. On the left-hand side, we've been working with the assets menu. Let's show you a different menu here. So we've currently been working here on the assets. We're going to navigate to a different level, which is the event frames, to show you how easy it is to start monitoring and comparing active and historical events such as pressures, speed excursions, pressure excursions, anything that has been valuable to collect. We've got event frames existing for those. So if I now click on the event frames on the left-hand side, I can choose to edit the search criteria. I can use the assets on display, choose an extended time duration, and then apply that as follows. And we've got a large range of event frames occurring between that time frame. We can create a table for those informations, meaning that we've got information about not just one pump, all pumps available to us on this display and the events that occurred for those. So this was to indicate how quickly we can get hands-on with creating display. At the moment, I haven't shared or saved this, but if the permissions were set, you'd be able to share and save this as needed across your organization. I want to now show you what the possibilities are when you use Pi Vision. If you spend more time really tweaking and exactly creating a refined dashboard. I'll give you an example of a water dashboard that we have created. This water leakage dashboard is to simulate a real life example of what customers may be doing for really enhancing the usage of their data. So they may have collected many parameters and information across their water network, but then they unify and use this in Pi Vision for real-time monitoring and real-time actioning of the data. So this simulation example is for a catchment within Singapore, as an example, that we haven't got real-time data. We're simulating. This is completely simulation, so there's no customer data exposed there. It's all developed in-house, but it's just an example of a catchment that exists in Singapore. Singapore is actually one of the best in terms of data water leakage prevention. The global target identified should be less than 25% water leakage across a network. Singapore actually operates at 5%. But just for the sake of this example, we've got a catchment that we're monitoring water leakage for. So in the center there, we've got an image portrait which has each of the catchments highlighted and then flashing when it's above set thresholds. And in this particular example, the threshold is 15%. So when it goes above 15%, we want to be alerted visually. So that's why it's flashing there. And similar to how I was showing you the visual representation on the example display, when we had the speeds changing color, you could have something flash like this as well with the same requirement. So that's alerting us to which area, which town, and we need to go and dive into to monitor for leakage information. But also the central dashboard is a navigation point to other smaller displays, such as we've got leakage information overall for our particular area across this area that we're monitoring, the total cost today and the total monthly cost of that leakage. You can see how much that is, the amount of water that is being consumed across these areas, the total flow rate regionally, and the real-time losses of the current day and then the monthly, and then what information we have about the region itself, how much meters of pipes are being used for distribution and for the mains, what area are we covering. So this is a navigation point a central navigation point. So you can have dashboards that are tied to one another and then navigate between one another quickly and easily. So now, for example, we started here and we want to go into the region or the town, for example, Jishan, that is above 15%, or Upper Thompson. So we can choose any of those that are flashing to find out more about what's happening. So I've chosen Jishan now. I've clicked on, so if we go back to the main display, so we've got again a navigation point to go back to the main display whenever needed at the top, as that's a fixed navigation menu that you can also define. Just by clicking on the name, navigated into Yushan, and we've got more detailed information about Yushan and the particular DMA. So DMA is a distributed area for that network, and it defines an area which you're monitoring the input and output for to be able to define the leakage. So you've got a certain input rate and then defining by the output how much you're losing. So in this case, we can see that DMA02F has got the highest impact in terms of leakage. So we could then go into DMA02F to find out what's happening in that area of Yushan. And then within the Yushan area, we've got again total cost, and then the cost per region as well, the megaliters consumed per region, and then the real-time losses. So more information, but rather than the entire catchment and entire region, we have just Yushan town that we're monitoring. Okay, now we've identified from this display, for example, that DMA02F is the culprit. You could go in and monitor what's happening with DMA02, what are the key parameters with that, and figure out what's happening in terms of key events. So we've got the monthly impact, non-revenue water there, how much water that we're losing that is essentially not making us any money. We've got the total cost in dollars of that impact. And then we've got on the bottom left here, if we remember earlier, our event frames. We've got some active event frames in place. So we've got the medium night flow, the mean night flow, which is outside of normal conditions. So that at that time frame, between 2 and 4, or a defined night time period, there should be a low flow rate, and this is indicating that at that time period there's a high flow rate, which is not matching up what our expectations are. So we can define within asset framework what your expected condition is, and then when you exceed that, it indicates something is wrong, and then we capture that to be able to troubleshoot why there is high leakage, and it's a focus point for end users to act upon. And then this DMA, we've got information historically about the leakage. If we wanted to go into it, see if it's a regular culprit, you can see it's constantly going above 20%, 30%. But more recently, it's been an offender. 51%, it's the focus point for any operator. And from here, we can navigate to other DMAs as well for comparison points. Okay, if we from there identified, okay, there is more flow, we can go into a detailed display about pumps and be able to figure out if there's a particular pump which is running at a low efficiency. And these are calculations that are made on asset framework. And those efficiencies are available to us here for us to then correlate against the leakage that is happening across our catchment. So what this dashboard and navigation allows you to do is create a real overview of what's happening across your business. It can take some time to set up, but once it's there, it offers insights that return a lot of savings for companies. And this water leakage is just one example. You could have many examples, such as pump monitoring for oil and gas. You could have, I can show you some other examples. For example, for oil and gas, downstream monitoring. You could have all sorts of equipment monitoring displays. And if we have another session, I can deep dive into those examples with you. But for now, that brings me to the end. I wanted to show you what's capable, or what you're capable with the AVEVA Pi software. the PI system, and the value that you can achieve with the AVEVA PI system. But now over to you, Gochukwu, if you want to open the floor for questions.
Thank you very much, Kazim. Thank you so much for this section, and also I think it's very educative. And I also want to open the floor to for questions. If you have any question, please just throw it in so that Kazim can attend to it. So let's just give 2 minutes so that we can have questions coming in. And also, it is very necessary that you try to join the WhatsApp group. The link is on the chat box. Please try to join it. We're going to be having other engagement on that platform. We're going to be having other engagement on that platform. So if you have any question, please just drop it. I will read it up so that Mr. Kwazim can attend to them. Thank you very much. Thank you. So I'm still waiting for some questions. Do we have any question? Please just drop it. So while we wait, okay, let me see what's there. Okay, so while we wait, I also want okay. Let me see what is there. Also, too, please, if you want to, the WhatsApp group is also open to system integrators, IoT, OT specialists. So far as you're an engineer and you're practicing, you're a student, you're a lecturer, you're in a school, you're working, please join the group because we'll be having a lot of engagement there. If you have questions, you can also drop so that I can read it up. And okay, hello, Daniel. Daniel, please go on with your question. You can write it down. We'll just read it. Please, Daniel, drop your question. So, okay, so Mr. Kwazim, can you see the question?
Yeah, see the question. The question is, when would you, what is the difference between carrying data via AF and then versus directly from PI tags in Vision? When would we use each of those? So it's referring to the option in PI Vision to connect to the asset framework. Let's navigate back for the sake of that question to PI Vision to show you what he's asking. In the assets menu, if we go to the home page on the left-hand side, we have the option to connect directly to our data archive, this icon here with the Pi symbol on top. Let's zoom in to show you a bit easier what I'm referring here. We have the ability to connect to the data archive directly or the individual asset framework databases. When would we use either of those options? So if you didn't have a hierarchy built out, which contained the data from the data archive, then querying the data archive would be essential to access that data. So the asset framework relies on data being available, but it doesn't mean that every single data information will be there. By having it in the asset framework, it makes it much easier for end users to navigate and find information. So if I wanted to find the vibration data, for example, for this pump FCC1 that I was given an example for, I would have to know the exact tag name, which I also don't know off the top of my head what that is. But if I was able to navigate directly here via the oil and gas downstream database, I can find all of the properties without even having to know what those properties are and if they existed. So it offers a much more intuitive way to interact with the data. But if you haven't got to the point where you've organized the data within Asset Framework, that's when you would directly have to go to the data archive. And then with that, you need to know the exact tag names, which makes it quite difficult when you've got thousands, tens of thousands of tags in your system. Hopefully that answers your question.
Okay, to Daniel, you can just okay. Thank you very much, sir. That is good. So okay, the first I have a question that somebody sent to me on WhatsApp. So I just wanted to know. So he was asking, how reliable is the data? How does maybe I don't know the system, or how do you tend to know that the data that is coming into the PI system is accurate? So that is the question that was asked. So I said, let me throw that to you. If
Yes.
it's something that you can also give a feedback to, is there a way to know that? Is it part of the system scope or the software scope? So I just wanted that to be answered. So somebody sent that to me.
Yeah, the reliability of data is extremely important, especially in certain industries, such as pharmaceuticals, where they need to know that the data that is existing on the source is exactly what they expect in the PI system. So a lot of data sources these days, they have historical data. The PI system itself does not give you a checkpoint to say this is reliable, but what it does require is that engineers that are setting up the system do so in the format that is required. But the PI system never modifies the data. The only time where the data can be different is if there's been an issue with the data collection. So if you're scanning a data source and the collection has missed a certain data point, then we have had queries about that in the past from customers about missing data because of some issues on their source system to collect the data. But if the collection system is efficient and running, we ensure that no modification is done beyond the point that they define. So you can filter out values if you want to, but that's not essential. You can have a one-for-one replication against your data source. You scan that data source on the frequency that you need to scan it, and you store at that frequency as needed. So, for example, in the pharma industry, there is a regulatory requirement that certain key data points be stored at a frequency every 5 seconds. So you can set up your data um, scanning on your interfaces, connectors, and adapters, whether that be on the interface level or at the source level. You can make sure the data is updating and available every 5 seconds, and then the PI system will be able to connect and store it at that frequency as well to meet regulatory requirements, and then in the end have reliable, trustworthy data in the PI system. So again, the PI system doesn't have any modification of data. The only time where data can be different is where you filter out, but you can easily change that to meet your requirements.
Thank you very much. I don't know if there are other questions. I'm not seeing any question on the chat box. So if you have any other question, please, okay. If you have any other question, please let me know. So somebody's asking, Blessing is asking, how are the security of these industrial systems ensured given the convergence of IT and OT? So that's a question from Blessing. He's asking the question. So it is very important that we have those coming in. So Blessing is asking, did you get that, Kasim?
Yeah, I just missed the first part. Can you repeat the first
Okay,
part, please?
let me repeat. Let me repeat. So the question is, how are the security of these industrial systems ensured given the convergence of IT and OT?
Yeah, yeah, it's a wonderful point to make there. You need to ensure security of your data end to end. So within the modern PI system, we have encryption of client connections to the data archive. So the central point of the PI system, where all the data exists and is stored, that becomes a critical point for accessing data. So the data security and accessibility needs to be secured end to end. So within the data archive, you can the data is stored in files, and then the location of those files, those drives, can be encrypted with any Windows or trustworthy encryption method. So the files themselves are not encrypted, but you can encrypt the machine and the drives in which data are located. For connections to request that data, they can be end-to-end encrypted as well. So whenever you access data via the web, there is an SSL certificate, TLS certificate, which exists, which means that the location that you access from is trusted. And that's the same for when you access data directly from the data archive. If you're connecting with, say, Pi Data Link, you can put in place certificates, which means that only the connection to the data archive can be made if the location that you're connecting from is secure. So there's TLS encryption and also SSL, which exists on the web layer, which means that data is encrypted end to end, especially when you're going to be accessing across your network. Hopefully that answers your question.
Okay, thank you very much. So the last question for today, Samuel is asking, is there a version to AVEVA Pi, or is it a cloud-based? However, what provision is made for small and medium-sized business cost-wise? So that's a question from Samuel.
Okay, in terms of the first, so a couple of questions sort of intertwined. Let's start with number one, the versions. Yes, there is regular updates to the software versions. We always recommend the latest version. So all of our key softwares, AVEVA Pi Server, Vision, Data Link, everything is regularly updated as and when needed. There's not a defined release schedule, but when a new release is made, notifications are given out to all of our customers about the latest software. So not that we don't support old softwares, we continue to support older versions for our customers, but also recommend that they use the greatest and latest features with the latest versions. There is many versions to the same particular software. Cloud-based, we have both the on-premises, but also being able to use the data in the cloud directly. So you don't necessarily have to have the entire stack the Pi server on premises. You could go directly from your source, which is adapters, into the cloud. There is a route which bypasses the need for the on-premises Pi data archive, asset framework, and such, the Pi server. But the common route is that a lot of companies want to have their data secure on premises before and then choose what they want to share in the cloud only. So it exists in a hybrid architecture for the most part. And then lastly, the question you had about the provision made for small and medium-sized business cost-wise, you don't have to purchase data archives with huge tag counts. You can start at the tag count that you need. The pricing is generally based on the size of the license. So if you have just 1,000 tags or less, you could purchase a 1,000 tag license. If you have hundreds of thousands of or millions of points, then you purchase the higher rate. So there's always an agreement that can be made with an account team to fit your needs, and further pricing and account queries can be taken up with your account manager. At the moment, I don't have any specific pricing information, unfortunately.
Okay, thank you very much. Thank you, Mr. Kwazim. I think this is a very, very insightful and very educative section. I believe that the participants must have gotten a lot of knowledge from this, especially when it has to do with the Pi system. And it's also important that we get to understand that this is a solution or a technology that is now generally or mainly being adopted, especially in the oil and gas sector, mostly in Nigeria, where you have a lot of this divestment with legacy assets. So for us, it is critical that we tend to educate engineers across scope, from very young engineers in the university, those practicing. And I was so surprised that we have a lot of people joining from different parts of the country. I saw somebody that was joining from Bauchi. When I saw it, I was excited. So for us to continue this engagement and for us to keep on engaging with you, I mean the participant, because I believe that we can get, no matter where Kwazim meets, we will get to meet him anytime. So, and I believe that Kwazim is very open to engaging young engineers, active, working professionals, especially when it has to do with this solution. So I'm going to put up the slide up. I will just put it up. So you have to click on the QR code. Sorry, I'm coming. So that you can be able to get into the. I'm coming, please. You can be able to get into the community. and we can engage with you further. If you have any further question, you may be able to ask. And also too, for those people that may be interested in using this solution, I think we have a lot of projects that we can work on together, because we're looking for, like I mentioned, we're looking forward to not just having this as a one-time section. We're looking at a solution where we can build a community of very young, active AVEVA users across the globe, or across really, because the fact remains that the technology is being adopted, the industry is adopting this, and also it is very, very important that the competence is being developed. So I want to say thank you, Kazim. I really want to say thank you for your time. And I also want to thank also the AVEVA team on behalf of Lunadec. We want to say thank you. And also I really want to say thank you to all the participants that came yesterday and also today, and those new ones that are just joining for today. It's a very wonderful experience from us. And we believe so much in giving back. I think this is a vision that the principal consultant, Dr. Ibilola, is very passionate about. And we are also passionate about it, where we can give back to our community and also develop technology within the engineering discipline. So for those participants that are very eager to continue this engagement, please, there is a link on the chat box. In the chat box screen, I have the QR code. We are looking forward to developing a very strong community. I think this is a series, like I mentioned initially, is a very structured series that we're having. So the section is not just going to be here only. Afterwards, after we're done on Thursday, we're still going to continue. We're building a community, and a very strong community that the AVEVA team can engage and also be able to drive this competence across our very, very active and lively engineers. Thank you very much. Thank you so much for coming, and we look forward to tomorrow. Tomorrow we'll be having a section by 2 p.m. tomorrow. The notification will be sent to everybody that have participated here and those that came yesterday. So you'll be receiving, just register. I think the link is already shared. So it's just for you to register and join for tomorrow's section. We're going to stop this on Thursday. I believe that we've been getting a lot of information. We're seeing the demos, we're seeing how the technology works. And I also believe that you are going to take this into your own job operations. Thank you so much. Thank you, Kwazim, and thank you to every other person that has made this possible. Thank you. Thank you.
Thank you. Thank you very much for the opportunity, and great to be and hope to continue this initiative in the future. Thank you.
Thank you very much. Thank you. We'll reach out. Thank you, sir. Thank you so much. So I'm still going to keep this on the screen so that you can let's do 5 minutes so that you can scan, you can join the community. The link is also on your chat box, so you can have it there. Just scan on this QR code and you can have this running. Thank you very much. Thank you. So while we did, I still want to emphasize the importance of us having this community going, and it's very important, very, very important that we have the community going. So please join, scan, join, click on the link. Please let us join. Let us build a very, very active and lively community where we can develop our competence in the AVEVA usage. There are a lot of portfolio, but at the same time, I think AVEVA has been able to categorize this into what we really need, into 5 major solutions. So I think it's very important that we build this community. We're going to be learning more. It's not just here. On that community, we'll be doing a lot of demos. We'll be doing a lot of engagement. Project scope will be shared. So it's good that you join and you build your competence. Thank you. So thank you, everybody. Thank you so much. Thank you. Thank you. If you have any further question, please drop it in the group. Drop it in the WhatsApp group. We'll share it with Kazim, and he will respond to it. Thank you. Okay, thank you very much, and do have yourself a very wonderful day. Thank